Hello everyone. Today we will be discussing the marginal revenue product. So as you can see, we got this nice little excerpt here for the formula of the marginal revenue product, but I'm not going to let you see that yet because we have to understand this excerpt first. So as you can see, I've already highlighted some things. So let's read this excerpt together. The chain rule can be used to develop the formula for the marginal revenue product, an economic concept that approximates the change in revenue when a manufacturer hires an additional employee. Start with R equals P of X, not P of X, P times X, where R is the total revenue from the daily production of X units and P is the price per unit. The demand function is P equals F of X, as before. Also, X can be considered a function of the number of employees, N. Since R equals P times X, and X and therefore P depend on N, R can also be the number of employees. It can also be considered a function of N. Sorry for that. To find an expression for dr over dN, use the product rule for derivatives on the function R equals P of X. So I'm going to hit pause right there, and let's try to understand this. First up, we have the chain rule. So the chain rule, as you might wonder, is like, it's like a chain. So per se here, I have a function. Say f of g of x. So here, the domain of f of g of x is g of x because it's inside our parenthesis. It says our domain. It's not our x. No, g is a function of x. So x and g of x are not equivalent. And you don't say f of x either. F of x is completely different from f of g of x. Because in f of x, x can be anything at once. But g of x is dependent on x. So they're not the same thing. So let's find what the chain rule is. Assuming that we have this function, think of it like a chain. So if we were to find the derivative of this, we would take, f prime of g of x times g prime of x. Or g prime x, depending on how you say it. Okay, and here, this prime that you see, it's for the derivative. So, like, here, if we want to find f prime of x, we would take f of x plus h minus f of x all over h. So, if you're curious about what this h here I talk about is, well, h here is just a very small value. Like, h it's not a variable. It's just like, say, 0.0001. Also, I know my drawing skills suck. Okay. We can just replace this x with g of x, but then we'd have to modify the denominator to be g of x, because the denominator is supposed to be x plus h minus x, which would lead to h, but here we now have, g of x plus h plus g of x. Minus g of x, which would still be h technically. And we also replace this x here with g of x. So that's the chain rule in a nutshell. This part at least. And the red part you see down there is just the formula for derivative. So back here, and no, I'm not going to let you see, you sneaky peek, you fellas. We're going to continue. Our next one, r equals p of x. Start with r equals p of x, where r is the total revenue from the daily production of x units, and p is the price per unit. So, what you could assume, what do you think? R equals p of x. Why am I saying what do you think? So, here it hinted that p is the price per unit, and r is the revenue, total revenue from producing x units. So it's safe to say that x is the number of units. So x is the number of units. It's a little note to self. So what we can say is that since p is the price per unit, we can also say that p is a function of x. So p equals f of x, or p of x, because it's the price per each unit. So let's go back here. No. Okay, anyways. Oh boy, why am I doing that? Okay, the demand function is p equals f of x, as shown here, surprisingly. And also, x can be considered a function of the number of employees n. So that's another note I should probably put here. You should remember as well. Okay, what should I write? What am I writing? Okay, what am I doing? Okay, x equals, not f of, okay, g of n. And what we can redefine p as is p, like p. Let's just say p of x, right? So p of x is p of x, but x of n. So what we're doing is that we're going back and applying this chain rule here. And this is going to come in action later in the excerpt. Just you wait and see. Go. Okay. So let's continue. Oh, I almost forgot to mention. Oh my gosh. Such a hurry. The R is the total revenue made from producing X units. So we could also say that R, here, let me change the color because I'm obsessed with it. R is R of X. We could write R of X of N as well. And it's really getting very connected and interbonded. And this is going to turn out very complex later. So back to the thing. No, you're not going to see it. Ha! I won! Let's go. Okay, anyway. Why did I say that? No, I don't mean that. Okay, anyway, so... Oh wait, I read that. Since r equals p times x, why do we keep saying p of x? And x and therefore p depend on n. R can also be considered a function of n, as we discussed right now. To find an expression for dr over dn, which is the derivative of r, or r prime, with respect to n. Because the rate of change of r over the rate of change of n. Use the product rule. The product rule. I wonder what that is. For derivatives on the function r of p of x. And I'm not going to read the next part yet, because we still have to process the product rule, and then we're going to have to guess what the function... What is the derivative of r? Okay, so I'm going to zoom in because I like to. So, where's it? Anyway, nice. So let's talk about the product rule now. Black. I'm going to use black. So... I'm going to write the words product rule. Product rule. There we go. My cursive sucks. If you're curious. And as you can already see. Anyways, the product rule. I need to get back to it. Anyways, this sucks. I'm just gonna say rule. Product. Hey, I just realized that. Okay, so the product rule is, if we have, let's say we have a variable a, and we have b, right? So a times b, we can just write as ab. And if we wanted to find the derivative of this, or we can write prime or d of x or anything like that, whatever you like to call it, dy over dx. Anyways, should get back to the zone. We can write this as, how do I say this? A times b prime, or d of x times b, or dy over dx times c, or dy over db, plus a prime times b. And if you're wondering, we can just go back to our little prime discussion here, as you can see, where we have f of x, basically just the derivative of that, or the rate of, we can just say this as the rate of change of y divided by the rate of change of x. So nice. Let's go back to our little thing. No. I wonder if y'all can hear me. Can y'all hear me fine? Oh no. Okay, anyways. Got that rule down. So, to get, I know y'all can see that, but let's just try to find what AB prime plus AB could be. So, So, what can A be here? P of x. P times x. Okay, so A is going to be P. And B is going to be, oh god, why am I putting that opening parenthesis? X. So then, we have P. Let me just change the color if you can handle that. P times, and then the derivative of x, or x prime, which is dx over dn, because x is a function of n. So, like, x in this case is like a y, and n is like our x. N is our independent variable. Plus x times dp over, drumroll please, dn. You might think that it should be dx because x is the independent variable of p, but like I said earlier, here p equals f of x, but if we look deeper, it's p of x of n. So let's apply the product rule over here. I mean, not the product rule. Let's see how we can get this. How the heck do we get dp over dn? It's quite simple, actually. dp, oh god, dp over dn is like, it's equal to d of p over d of x times d x over dn. Basically, it's just equal to, let me just change the color real quick because I'm a psycho. We can express this as p prime of x, like p, the derivative of p with respect to x times x prime with respect to n. I wonder, where else have we seen this very equation? Guess what? It's the chain rule. F of g of x times f prime of g of x times g prime of x. And f of g of x right here. I don't know if you already know, but yeah, it's true. So, anyways, let's check if this equation is true. Oh, I'm giving you lots of time to look at the marginal revenue. Okay, so we covered this part, dp over dx times dx over dn, and p times dx over dn plus x times dp over dn. So yeah, we were right. This is correct. So if you were wondering, we have dx over dn and dx over dn. So if we replace dp over dn with this, I wonder, what could we do? So let's do this. So we will start with our formula over here. Let me just rewrite that with red because I'm neglecting red. Okay. Oh my gosh, okay, D. Oh my gosh, there's not enough space. Okay, so I can still write P times dx over dn. And But the change here is in the plus. But before I put this here, I want to address something. Here, oh wait, why did I put dx over dx? No, this is horrendous. Oh no, oh hell, I might have cursed. Why am I, oh, that's not curse. It's just bad. I shouldn't be saying this. Okay, so, how I got this is kind of like pretending to cancel out. And by pretending, I mean pretending. This actually does not work. We just use it because it's kind of more convenient to teach. Because it's not really easy to explain kids like me or you or whoever's watching this video, or any kid basically who's taking this course, differential calculus, how else to resonate dp over dn. So yeah, that's an important thing. dx and dx don't really cancel out. It's just, we just use it. Us TAs, teacher assistants, and teachers, we just use it because it's more convenient for teaching. Okay, so that was an important note. So back to it, we have plus d, oh my gosh, I forgot the x. What is wrong with me today? Times, I'm going to put this in yellow because, no, I'll put this in blue, fine. I'll put it in blue. Okay, dp over dx times dx over dn. And I'm going to enclose this parenthesis. Now, I'm going to let you think. I want y'all to think. What could we do? Couldn't we take anything common? Could we somehow simplify this? Hint, hint. I'll let y'all think. Okay, you got it now? So, if you still need some more time to think, I'm just gonna make this fit. I'm gonna let y'all see all this and pause the video and take a look at all this. Pause it right now, and no, actually don't, and then see this stuff, except for that. No, do not see that. I'll just, oh god, that's even worse. Oh god, that's even worse. Okay, nice. Look at that. Okay, we done? Okay, so I'm gonna move on now, and I'm gonna put this back at 200% because I feel like it, and I'm in the mood. Okay, so we're gonna take, as you can guess, dx over dn common. So, I'm gonna write dx, no, actually I'm just gonna put this first, p plus x times d, oh wait, the parenthesis isn't good. My god, golly. dp over dx, and we have to remember this dx over dn is gone. It's not there. We took it out. And by took it out, I don't really mean take it out, because in reality, we're just keeping it right outside the parenthesis. Maybe green this time. dx over dx over dn. And this, my friend, is what the marginal revenue products equation is. So, if you need more practice, or if you need to look at the thing more carefully, then at the excerpt more carefully, or in a moment here after I do this dr over dn, this is dr over dn, the marginal revenue product. We're gonna see what it actually shows, and then I'm gonna give you a practice example and put what you think is in the comments. Okay, so here's the thing. Pause the video. Feel free to read it again. This is a footnote I put when as I have the book. This is the equation. Factor out dx over dn. Expression for dr over dn gives the marginal revenue product. Okay, now here is our practice problem. Example 12. Find the marginal revenue product, dr over dn, in dollars when n equals 20. So, x is a function, and let me just put it, how do I, yes, x here, right? So dp over dx, we want to find, oh wait, I need to teach y'all one more rule before you're ready to tackle that example. Okay, so, what is I'm thinking? What stupid idea am I thinking? Okay. So, screw it. No, wait, not yet. I'm still thinking. Oh, yes. The generalized power rule. So the generalized power rule. I'm just going to write PR because I don't have much time. So, let's say we have x to the power of n, and not canonically, like in here, this x to the power of n, but like, we have x to the power of n, right? So, say we wanted to find the derivative of x, or say, this is y. So, if we wanted to find y prime, that was going to be equal to n, like this n, hold on, let me get the laser pointer, this n right here, we're going to multiply that by x to the power of n minus 1, and we're not done yet, because this is yet another example of the chain rule, f prime of g of x, which can be said as dp over dx times x prime, like this lone x prime, where x is like a function of a number. So that's it, folks, for today. And I'm going to give you a little hint. Here, dp over dx, right? This dp over dx is, hold on, let me change the color, is this. And dx over dn, I'm going to put in a different color, is this. So, dx over dn and what is it called? Yes, dp over dx. Oh, I should probably use a different color to, yeah, red. dp over dx. So I'm gonna give y'all a couple of moments to look at this. Pause the video if you like, and then we're gonna move on to the example. Okay, so let me 20%. Okay, so find the marginal revenue product, dr over dn, in dollars when n equals to 20 if the demand function is p equals to 600 over root x and x equals to 5n. So I'm going to give y'all a startup, okay? So we can write 600 over the square root of x as 600 times x to the power -1/2. And x equals to 5n. So we find the derivative of this times the derivative of 5n. Hint, hint, it's the coefficient. Or I'll just say it's 5. So just solve this and then plug it in our equation. If you've taken notes, or if you haven't, it's right here. Put your answer to comment, like and subscribe. Have a good day, folks. Goodbye.